All right, so our senior project is IntelliReview 2.0. We're sponsored by Language Intelligence, which is located here in Rochester, New York. And our team consists of Tim Henderson, me, Alexandria Infantino, Jesse Rue, and Emily Filmer. So who is Language Intelligence? It's a company here in Rochester that offers a variety of language translation services that include document translation, language training, consulting, and interpreting. Essentially what we're doing is rebuilding an old piece of software that the company uses. Primarily the software allows users to create projects which include files of translations. Within those translations, reviewers can enter those translations and provide comments and suggestions on how to change the translation so that it is translated cleaner and easier to read. Essentially, the old project had some performance issues, so document parsing took a long time, and we're trying to clean that up, as well as the software is used by people that are located across the globe, so speed is important in that aspect. There is a lack of real-time capabilities, so we're working on allowing documents to be collaborated on by many people. There is user management shortcomings, so the old roles that existed were very concrete and hard to extend and change. So we're working on making it a little bit more flexible and allowing new roles to be created easier that have a different set of privileges. And overall, the project was not a ton extensible and flexible, so we're working on making our new project more modular so that it's easily extendable if new features need to be added in the future. Our solution?
In steps IntelliReview 2.0. We were enlisted by Language Intelligence to write the new software because IntelliReview 1.0 is starting to show its age a little bit. It was developed before the advent of HTML5. It doesn't utilize jQuery, and nowadays it only functions properly in Internet Explorer, which is a problem for the modern web user who wants to have a choice as to which web browser they use. Despite these shortcomings, IntelliReview did and does what it was designed to do. It allows translators to review already translated documents and offer comments and suggested changes, things of the like. And so for that reason, we're not here to blaze new trails. A lot of the functionality from IntelliReview 1.0 will be ported into IntelliReview 2.0 with a few polishing features, and it will be written with modern tooling. So we have a special interest in running with Google Chrome and Mozilla Firefox, some of the more modern day browsers. And one of the key features that we will be implementing into the new version of IntelliReview is simultaneous document editing, so more than one user can review the same translated document at the same time. In addition to that, we'll be required to expose an API for some of the more major project functions, such as creating a new project or uploading files. Sure.
So in order for us to address some of these shortcomings, like Tim mentioned, we're going to be leveraging some modern technologies. We also want to have a focus on improving some of the security practices. At the moment, IntelliReview has a few holes in it that we would like to patch up. Like we mentioned before, with the user management not being terribly flexible, we want to make sure the user permissions and roles are customizable at runtime, so you don't have to dig into the code if you want to make changes. Additionally, we want to make sure the UI is simplified. We plan on adding some more information to the page, so it's going to be important that we don't clutter things. We also want to reduce the number of clicks per task. As mentioned before, a lot of the clients that are using this can be halfway across the globe. There's latency issues. We want to make sure that they can be productive when they're using this web app. Finally, we want to be mindful of language barriers. Some of the users of this app aren't very tech savvy. They're also may not have English as their first language, so it's important to make sure that our wording is not ambiguous, clever use of icons and symbols as well. So for some of the technologies we decided on, we're going to be using Django, which is a Python web framework. We'll also be using React, which is a JavaScript library for creating front-end UIs. And we'll finally be using Node.js to run as a small server, and Node.js is a JavaScript runtime. So why did we choose these? We chose Django because it comes prepackaged with a lot of solutions that are relevant to us. There are a lot of things in web development that you're probably best left, letting the professionals take care of that. This includes things like user authentication, permissions, and an admin panel.
We chose to use React for our UI because React is a hugely popular JavaScript library nowadays. It's got a thriving community of passionate developers behind it. It's heavily documented, and it's really good at creating dynamic UIs. For an application that's so front-end heavy, it seemed like a logical next step. React itself is extremely modular, and it'll allow us to easily reuse components, which is good for during document reviewing. When a user wants to leave a comment or a suggested change, these are elements of the page that will be reused countless numbers of times. React will make that easy. It also utilizes something called the virtual DOM, which it offers plenty of performance improvements because it compares the rendered DOM to the new DOM and only re-renders the portions of the page that need to be changed. In addition to that, it uses a syntax called JSX, which makes writing these reusable components simple and easy.
And finally, for Node.js, as mentioned before, we plan on adding in some real-time capabilities so multiple users can be working on the same document at the same time. Node.js makes this easy. We can easily integrate with WebSockets and have Node.js act as sort of the middleman between the browser and Django. Additionally, Node.js allows us to easily manage the user sessions as users are working in the editor. And because Node.js is a single-threaded process, we reduce the risk of data races. Additionally, just overall why we chose these, our team has experience with all of these and we felt comfortable using these technologies. So for some of the design, starting off, there are a few obvious quality attributes that we pulled out during requirement solicitation, and those would be performance and usability. For performance, some of these documents that clients are going to be reviewing are very long. So it's important for us that when these documents load into the page load time sort of remains constant. We don't want load times to increase drastically as document size increases. So this we can leverage with something like dynamic loading. Also, we want to make sure that if multiple users are working on the same document, that those real-time changes are with, as real-time as we can make them to be, with minimal latency. So if user A makes a change, user B sees it as soon as possible. So there's no likelihood that the users are overwriting each other's changes. Finally, for usability, as mentioned before, we want to minimize the number of clicks to perform a task, and we would like for some key tasks to be able to be completed within a certain amount of time, regardless of the user that's performing the task. This is just a simple domain model that gives you a better idea of what the system actually is. The system has projects which contain several files. Those files will be accessed by both the translators who generated the files and the reviewers who are the clients. The clients in the translator can make suggestions, and the translator is able to accept or reject suggestions made by the client. Additionally, there's feedback through the means of comments. And finally, all of this is managed by a project manager internally at Language Intelligence. In order to handle the dynamic nature of the roles, we came up with this. Essentially, we have a table in our database for roles, and these roles are associated with a set of privileges. The unique part about it is that roles actually sort of reference themselves, because in the case of a user creating a new user, that user can assign that user a role. We want to make sure that we can limit what roles get assigned. Because we're kind of abstracting roles, we're no longer hard coding them. We don't really have a concept of a project manager. Though we'll have a role for it, the code doesn't really understand what that is. So we need to be able to make sure that we can manage that appropriately. And finally, probably the most difficult part of this whole project has been the document parsing. The files that we're working with are in a proprietary format, and there's very little documentation around what that format means. So our solution to this is to try and load the document in, abstract it as much as possible so we can move away from the document format itself. We can then take these elements, which could be sentences, for example, and the sentences are translatable. We can assign IDs to these sentences, pass those elements into React, and then when changes are made to those elements, we can simply track those changes on a per ID basis within the database. And then finally, when it comes time to export the document, we just look through, replace the IDs based on what's in the table. We do very little work actually, getting our fingers dirty in the document itself. We only do it at the very end. And all of this parsing has been followed by extensive unit testing.
So moving on to our process. Some of the tools we're using Slack as our main form of communication among the team and also with our faculty coach and the sponsor. We're using Git and GitHub for our code and version control, and we have a process in place for when you want to merge your changes into the master branch. You have to create a pull request, and it has to be code reviewed and also tested before being approved to merge into master. We started using Trello for our task tracking, but then we migrated over to use Jira because we felt it would help us track our story points metrics easier. And we're using the SE webpage to track our hours metrics, and that also has the project synopsis. So the first few weeks of the semester were dedicated to requirements elicitation. So a number of our meetings with the sponsor were mainly focused on high-level discussion about what the project was, what value we could add to it, what the main priorities were. And obviously, while a lot of this was functional requirements, a good bit of it was also non-functional in terms of what programming language we would use and also what frameworks. As previously stated, we went with Django and React, but that was after quite a bit of deliberation back and forth, figuring out what would be the best solution. But once we had those decisions made, we moved on to break down the high-level requirements into independent tasks as user stories, and the prioritization of those stories happens at the beginning of each iteration. Which brings us to our methodology. We decided to go with spiral methodology because we wanted something that was incremental and iterative. One of the main benefits of spiral is that it is a prototype methodology, so we felt that that would provide a lot of value to our sponsor, and also for us, we could consistently receive feedback on our progress. So the phases, each iteration is broken up into: first, we have planning and risk analysis. That's the first week. So we take into account what risks we have in our risk chart, and with those in mind, we prioritize the backlog, select the top stories, and we've been using a Planning Poker web app to assign story points. And then we move on to 2 weeks of development, and then 1 week of testing and evaluation as the final phase. So that's kind of our opportunity to do integration within the team, last chance for pull request approvals, and we kind of get our code base all back on the same page. In evaluation, we have the opportunity to update our process if something could have gone better for the next iteration.
So our team has been pretty good about religiously meeting every week. On Tuesdays, we meet with each other and we do a sort of team check-in, discuss any sort of blockers or problems that we're having internally. This also allows us time for design work as far as how the database will be structured and UI mockups, in addition to any sort of help that any other developers need. And then on Thursdays is when we have the time allotted to meet with our sponsors. The night before, we'll email them the meeting agenda. We'll do a quick review of the progress we've made since the last time we met. We'll overview the 4UP chart, which we created, and then once again, we'll address any main blockers or questions we have, again, in addition to the requirements elicitation that we've already done.
So for our metrics, we've been tracking hours, both on an individual basis and as a group. And also we've been tracking story points so we can calculate a velocity, so we'll better be able to predict how much we can get done in an iteration. We've only finished 2 iterations so far, so those values aren't super helpful yet, but they will be in the near future. Also, we are tracking defects in terms of pull request rejection rate and acceptance rejection rate. But as of currently, since we've been working on mainly foundational work of the project, we don't have much to show for that just yet. And for risks, these are the main 3 we have on our risk chart. The first being collaborative document editing. So that's one that we haven't encountered just yet, but we see it's right there on the horizon, coming up soon. That will definitely be a priority once we get to that point. Permissions and privileges is something that kind of snuck up on us. We didn't realize it was going to be such a big part of the project layout and structure, how it was going to work. So we've been spending a lot of time on straightening that out, getting everything back on track, which will save us a lot of time in the future. And then file parsing, which has been a known risk since the beginning of the project, and it has been our main priority because of the proprietary document format and the compatibility of the documents.
We'll talk about testing a little bit real quick. So as we've mentioned already, a big part of this project is the document parser. And since that is so huge, we have unit tests written for that already. Since this project is initially being developed by us, and we're aware that in the future it's going to be passed off to either IntelliReview or language intelligence developers, rather, or possibly another senior project team in the future, we're acutely aware of how important it is to have a robust test suite to make sure everything that functions properly. So we have unit tests written for the parser. As the project starts to flesh out a little bit, we're going to be looking towards creating integration and browser tests. We're looking to use, Django has a test framework that we're using for the parser currently. We're going to be using Jasmine for the unit tests for the UI, and then Protractor and Selenium WebDriver for the integration tests in order to properly mock user interactions and just make sure that the user interface responds in the ways that it should. Again, with testing, one of the things that we're worried about and aware of is that nobody on the team has any experience with writing the collaborative document editing portion, let alone testing it. So that's something we're definitely going to have to research a little bit more. And as far as our hopes for the future, we'd really like to set up a CI/CD pipeline to streamline the development process a little bit, have the tests run a little bit more consistently, and just be able to deploy builds more frequently. And for that, we're looking into using Circle CI in addition to a couple of other CI technologies.
All right, so current status of the project, we have our basic skeleton laid out. We've completed 2 cycles of integration, like we talked about, and that was primarily focused on authentication and project creation. So we have the back-end logic of that created. We have our roadmap planned out for the next semester, and we have checkpoints that we need to reach in order to complete the project on time. And then we have project details fleshed out with our sponsors, as well as some mock-ups and wireframes for the front-end portion of it. What we're working on now is we continue hashing out feature details and discrepancies with our sponsors. We're currently working on the document parsing. As we said, it's a large feature and it's taking time to work on. We're currently working on the front-end implementation, so clearing up the front end, making it smooth and easy to use with our back-end that we've already had implemented. And then we're also working on database design for the different objects we need to interact with and how they relate with each other, as well as any unfinished features that are in the back-end that have yet to be worked on. Our plan moving forward is that we do not plan on changing really anything that we're doing drastically. It seems to be working out right now as it is. We're going to continue doing the 2-week development cycles, and we're going to continue assigning tickets to developers each iteration. It doesn't seem broken right now, so we're not going to worry about fixing it, essentially. Any questions? Cool.
There's got to be somebody that has a question. I have one. a similar methodology. Talking about your methodology, so you seem to be very, your application is very forward-facing, and you're looking for a lot of feedback from your customer. Why did you choose Spiral over, say, like an Agile methodology?
I think that Agile kind of has some more extra things in there we didn't need specifically. Well, it is kind of.
So the question was, why did you choose the spiral methodology over something a little bit more agile? And I think the backbone to that answer is that once we elicited the requirements, there is a clear goal in mind for this project. We've gotten to look at IntelliReview 1.0 and we sort of have an idea of what it's supposed to do. And for that reason, we didn't need to be able to respond to changes as quickly as you normally would when you're using an agile methodology. So we thought from the beginning that the prototype would be more beneficial. We can sort of come up with what we want, we can bring it to the sponsors and they can tell us what to tweak, but for the most part, we hammered out our requirements from the beginning and we felt pretty confident in that. Yep.
So for your front end, are you doing any kind of process for your design, like just building out
So,
or is it just free roam?
like in terms of developing it,
Yeah.
so we met on our Tuesday meetings like we were talking about, and we essentially hashed out a wireframe of how it should look and how we think that it would work best and be easiest to use, which we brought to one of our sponsor meetings to show off, and then kind of had a discussion with what we should change and what parts we should tweak to make it better and kind of conform to what they're looking for.
Additionally on that, as we mentioned, one of our quality attributes is usability, and we have a couple things in there such as clicks per task and also task time. So we don't have those tasks ready yet. Next term, once we have some tasks ready, we could do some testing. Maybe we could just pull in some random students, maybe some people who aren't super tech savvy, just try it out and see what kind of numbers we're getting. Yep.
How are you using Django to drop with React? Because as I understand, Django is more of a template-driven framework. So how are you using that with React?
Right. So at the moment, right now, we're essentially using the templating to inject data when we render the page. So basically, we'll have a JavaScript block at the bottom with some JSON in it if we want to insert data that way. For the editors, because we want to make sure that the page loads quickly, and for those really large documents, we don't want to send this huge blob of JSON. That's when we can start using something like WebSockets to stream the data as the user scrolls down the page.
Okay, let's send the team.
All right. We are Gadomski & Co., and we've been working on the purchasing and inventory control system for KGCOE's multidisciplinary senior design. So what is multidisciplinary senior design? MSD is similar to software engineering senior projects, except that lots of different majors like biomedical engineers, mechanical engineers, computer engineers work together on a physical project. So currently there are 450 students enrolled in MSD on 80 teams. So PICS, the purchasing and inventory control system, it's necessary because unlike SE projects, those students actually need raw materials, wood, metal, circuitry to build their projects. So there's a budget that students are given at the beginning of the project, and they need to keep track of that. So PICS facilitates purchase requests, budget tracking, and inventory control for, keeping track of the tools that are available for students to check out and use.
So what is our main goal here with this project? As you just heard, the PIC system has been incredibly beneficial to the Kate Gleason College of Engineering and MSD programs, but with that extensive use, it has shown a lot of wear. So it's estimated potentially 50% of a user's time could be saved. For example, right now the budgets all currently exist in an offline spreadsheet, so if there's a change to a budget, they need to leave the PIC system and go to the local copy of the budget. In addition to that, there's no way to update submitted purchase requests. So if a team wants to order some parts, they submit a purchase request. Once it's submitted, a student guide needs to approve it before it can actually go through. And in between that time where they submit it and it hasn't been approved yet, there's no way to edit it. So if they did want to submit a new one or edit what they put in, they would need to go to the purchase request, cancel the entire thing, and then start over again. So our project focal points are going to focus on all three main subsystems that make up the PICS system. So we're going to provide updates to the purchasing system, look to completely integrate the budget system directly into PICS, and as well provide updates to the inventory system. And so when we were determining what type of technical process we wanted to incorporate with the project, we needed to take a step back and ultimately look and see what we needed to do. So PICS is an already existing application, and a majority of the changes that we would like to put into it have to do with broadening or extending the functionality. And so given that, we opted to utilize an iterative/incremental methodology. And so each iteration consists of 4 main stages: requirements, where we look at what requirements we want to tackle that iteration; analysis, design, and implementation, where we look at how we're going to implement the changes, as well as actually implementing the changes; testing, where ourselves and the sponsors will go through and try to and test the changes that we put into the staging environment to see if it's messing with anything else. And then the evaluation stage, where we as a team will go back, look over our progress over the past iteration, and see whether or not there's anything we need to change or any process changes we need to make. In addition to those 4 main stages, though, there is also the initial planning and deployment the initial planning and deployment stages, which happen at the beginning and at the end. And in addition, we're also given 4 weeks per iteration to complete our tasks.
Thank you. So in terms of eliciting our requirements, we were very lucky to have some excellent sponsors to start out with. So they gave us a big list of the requests coming from themselves, lab assistants who are responsible for approving purchase requests and generally keeping the system running, and the students themselves, including the sponsors. So all of these people are using this system every single day and have encountered all the issues that cause them hours upon hours upon hours of inefficiencies. So we were given this list of different requests that we knew would make a positive, immediate impact on the use of the system. So all we had to do was take our software engineering knowledge to convert these requests into a task-by-task breakdown on what exactly we need to do. So once we had these tasks, we then decided to keep the task definitions at a high level initially, and then during the iteration themselves, so while we're actually developing this piece of software during the iteration, we are gathering the more detailed aspects of the requirements. We do this to make sure that our domain knowledge and the knowledge of what needs to be done for the task is well understood at the time of development and isn't just stuck in some Trello card somewhere for the 4 months that nobody really understands what the point of it is anymore. This is facilitated by the fluid communication we are able to keep with our sponsors.
So here is the high-level domain model of the system. This was one of the first documents that we came up with in our initial conversations with the sponsor. This just gives us a high-level understanding of the business logic behind the system. I'm not going to go into too much detail, but the main takeaway here is, as we mentioned before, there are 3 main subsystems, which are the purchase requisite, the budget, and the inventory subsystems. And you'll see how that affects our software tasks, how we categorize them, and how we group them in the iteration schedule moving forward.
So as for the actual scheduling, so once we had that list of tasks that we knew we had to execute, we were then able to create a work breakdown schedule, grouping these tasks into different epics. So the purchase request epic, the budget epic, and the inventory epic. Once we had these epics and all of these tasks, we then created estimations using hours. So why did we choose hours? We chose hours because we knew that we wanted to be able to compare our estimations to the actual amount of time it took to complete a task. If we continue to be either over or under in our estimation, we could then go back to the drawing board, re-estimate the rest of our tasks, and make sure that we deliver exactly what we promised to the sponsors by the end of the project. So once we knew we were estimating with hours, we then used a method similar to planning poker in order to do the actual estimation. So all of us had a spreadsheet individually that we entered in our estimates per task, and then we all got in the room together, went 1, 2, 3, and then yelled out how long we thought the task would take. Once we had this, we were able to take the least amount of hours, the most amount of hours, and upon some disagreement, eventually consensus, the most likely amount of hours. From there, we used the 3-point estimation technique to get our final estimate. Once we had these estimates, we were able to schedule out our iterations to make sure that each iteration hits an average amount of hours so that we're neither front-loading nor back-loading our work, and ensuring that we do a consistent amount of work throughout the entire project, taking into account, of course, the schedule that the sponsors would like things to be done by. So let's go into some of our iterations. So iteration number 1 was mostly project kickoff. We also handled some of the purchase request tasks. So this previous fall semester has pretty much entirely been purchase request work. So iteration number 1 was that. Iteration number 2, we had to call a little bit of an audible. So initially there was a request for a reimbursement request to be built into the system. After some discussion with the sponsors, we all agreed that this was entirely too complicated to be able to handle in 4 weeks. So with the help of the sponsors, we decided to go with budget increase requests, which provided the same amount of utility to the lab assistants and students, while still being a lot easier to develop within the iteration period. We also built in new authentication structure into the system. So previously, only members of KGCOE, or only students enrolled in KGCOE, were able to be in PICS, which is unfortunate because we have a lot of students from other majors. We even have some accounting majors within the system. So by making this modification, we allowed for anybody enrolled in MSD to be able to use the PICS system, which is a massive upgrade from where it previously was. Finally, during iteration number 3, which is our current iteration, we are currently finishing up with the purchase request work. So by the end of this, we expect all purchase request work to be complete on the system. So looking forward into the spring. So iteration number 4, we are going to begin the budget work. So as Ryan previously mentioned, the budget system basically needs to be built in from scratch within the system, replicating the functionality that are currently just sitting in spreadsheets on the sponsors' computers. So we expect this to take iteration number 4 and most of iteration number 5. Now finally, we have some inventory aspect work that we need to complete. However, there isn't really too much, and for the most part, this module works pretty well. So this work will be done in iterations number 5 and 6. Finally, during iteration number 6, we understand that we are not going to be the last team to work on this, and that people are going to have to work on the system after us for quite a bit. So we wanted to create the best technical documentation we could possibly create and provide the cleanest code possible to ensure that anybody who goes into the system and has to modify the system can almost immediately understand how it works and pick up and develop off of our work. This is just a good software engineering practice, to be honest. So where are we now? Currently, after iterations number 1 through 3, we are almost done with the purchase request system. We expect it to be done by iteration number 3, which will end at the end of the semester. And we expect to do a production push over winter break so that the students and the lab assistants are able to take advantage of the great work, the great features, and the great upgrades that we've created for the system. Coming back in the spring, we will begin iterations number 4 and 5, which will include porting in the budget into the system. And then during iterations number 5 and 6, we will begin working on the inventory tasks that we need to complete. So overall, I'm happy to report that we are exactly on schedule. Despite the hiccups, we've been able to overcome all of them, and we expect to be on schedule for the rest of the project and to complete all the things that these sponsors wanted us to complete. Nope, sorry.
So over the course of the project, we've been keeping tabs on some metrics to give us a quantitative idea of how well we're progressing. So a couple of those are estimation of hours of work delivered each cycle. So that's congruent to the concept of velocity in Scrum. So we can just look at the amount of hours each task that we took for that iteration. Look to see how many hours they were, and then we can take that, add them all up, and then compare that, or average it with all the other hours after each iteration, and then we can kind of get a baseline idea of how much work we can put out per iteration. We're also looking at total hours logs. So in the case of that, if for whatever reason we're slipping up on the schedule at all, we can look and we can see, oh, maybe one of us needs to, or someone's not working on their project enough, or maybe we overestimated that task or underestimated, and we need to go back on the drawing board. Also, average estimation deviation. So when we initially assigned hour values to all of the tasks, we keep track of those, and then after we complete an iteration, we can compare how long it actually took us to what we estimated it to be, and then we can see if our estimations are typically overestimated, underestimated, or right on track. We're also keeping track of 4-up charts every week. So as you can see, there's a picture of 4-up chart, as we've all seen. Keeps track of your progress, risks, plan, and needs, and it's a really good snapshot that the team can look at to make sure we're all on the same page for that week. And we're also, another basic metric we're taking into account is the number of emails sent between the team and the sponsors, and that's just a good way to make sure we're in constant contact with the sponsors in case anything comes up. So as of right now, the design of Pix was made as a single-page web application, which was made possible via AngularJS. And so you might not know what I mean when I say single-page web application, but if you've ever used Gmail, Facebook, or Twitter, those are all examples of single-page web applications. And so those are actually very user-friendly. So if you recall using Facebook or Gmail, when you click something, or when you're trying to do an action, it doesn't reload the whole page. It just kind of dynamically updates the content that's on the page. And so that gives it a really smooth and responsive feel to users. And another benefit of single-page web apps is it reduces server calls. So we'll take that. Cons of single-page web applications typically consist of potential security concerns. So in order for single-page web apps to work, you need to have JavaScript enabled on your browser, and that actually allows another attack vector for potential malicious users to come into. Thankfully, we're not going to have to worry about that too much, so the downsides we don't really need to worry about. As far as the actual application layout, it's generally pleasant and easy to use. It features a main navigation bar at the top, which is fairly consistent across all standard applications now, so users can easily get to each part of the application that they need to. There are a couple pages which we feel could be tuned, such as the dashboard and filter pages. There's some clutter there and some screen real estate that we feel we could use better. But overall, it provides a generally satisfactory user experience.
Okay, let's talk about some of the development and testing. As we said before, this is using an Angular for our web framework and PHP for handling the SQL database communication. We've hit a couple of roadblocks, and this is mostly because of the environment that the system was set up in. Right now, it's set up in clause with a staging and a production environment. Usually when you develop a web application, you do it in a local environment so that you can make a change in your IDE, save it, and then quickly see how that affected the page in your local web browser. However, in this case, in order to push any changes, we have to make the change on our local machine, commit it to the Git repository, SSH into the staging machine, pull those changes, and then we can see the changes on the staging web browser. So it's a really long process, and it really is not conducive for quick development. However, that's what we've been forced to use. In the first iteration, Ben and Grant put about 30 to 40 hours into trying to set up this system in a local environment to speed up development time. Unfortunately, that didn't really produce anything useful. It was a dead end, but that actually caused a couple of tasks from iteration 1 to roll over into iteration 2. However, we were able to quickly catch up on those. And also, another roadblock, the initial system was not built by any software engineers. I think it was actually a mechanical engineer. So the design practices, they were not the best. There was really poor documentation, and the system was a little spaghetti code. As far as testing goes, we have our sponsor test every task, so we're able to get that signed off, saying that we have successfully satisfied the requirement. In the future, we also want to work with student teams and the lab assistants that use the system. That will just be able to allow us to test all possible use cases. For now, the purchase requisites we've been able to test mainly with just the sponsor who acts as an admin in the system. But in the future, we want to get all use cases. Some of the risk management, a lot of the risks that I went over in the last slide. We have changing of requirements, scope creep, underestimation of tasks, potential to break the current PIC system, and outside class demands. So we've encountered a number of risks while developing. First off, as I said before, the development environment. Right now it is in clause, and clause is really difficult to work with because of the staging in production as opposed to a local development environment. We've had some issues pushing fixes to the production environment because the production doesn't look at the same Git repository as the staging directory, so it's kind of a mess. Requirements changes, as Grant said before, we had to change the requirements for iteration 2. Luckily, that was a very clean swap out, but in the future, that's something that we want to keep in mind going forward. Scope creep. In some of our meetings with the sponsor, some of the students that use the system have gone to our sponsor and said, hey, there's this really cool feature that we'd like to have. However, when the sponsor brings it to us, it's quickly apparent that that feature is really not in the scope of this project and would be very difficult to implement. So with that, are there any questions?
Yep.
Well, I may have just missed this, but what is it about the project that makes it so difficult to develop locally?
So it's built into the clause architecture. So that's a system used within RIT to basically serve as server storage.
Yeah.
I'm correct? Yeah. So we worked with, what was the final system that we worked with?
The network administrator for basically all of our IT.
So we burned through at least like 4 or 5 different system administrators.
Yeah.
So what was the ultimate issue again? I can't.
The major issue is that the application needs access to user data, and getting permissions to do that in a local environment, or even just mocking it with stubs, it wasn't possible.
So it's firmly built into the way that RIT stores all of the student data. So RIT stores your major, your username, et cetera, and it basically uses that RIT central storage to do all of its student authentication. Trying to copy this down into a local environment and trying to get those connections to work together turned out to be completely impossible. So there was no way from a local environment to get the permissions to connect up to that RIT, what's known as Active Directory, which is how it stores all student data. It was impossible to do that, get the permissions from a local environment. And it was also impossible to copy that down because of security reasons. So ultimately, that became the main issue that we ran into. Anybody else?
How much refactoring did you have to do?
There's been some refactoring. We haven't done a ton just yet. Most of our focus as of late has been more on delivering features and delivering tasks. Now, when we can, we do refactor and improve the code when we run into a piece of really awful code. We are absolutely planning on spending the vast majority of iteration number 6. So the last 4 weeks of development in this project are almost entirely going to be technical documentation and refactoring. So that's when we're going to do a full refactoring of the system to make sure that the code that we hand off is as high of quality as we possibly can get it to be. Anybody else?
Yep.
Do you plan to write the unit tests so that when you do that refactoring, you know you're not very
Unit testing, so we did research unit testing. So this is Angular built off of vanilla PHP, which vanilla PHP is actually surprisingly difficult to unit test, especially within a web application. I remember so I actually was on co-op with vanilla PHP at Sherwin-Williams, and even this professional team looked at it and decided that it was entirely too difficult to implement. So we'll continue looking into different options, but overall, right now, unit testing isn't as important to us as integration and regression testing, which is done more point-and-click as of right now. So we'll be doing quite a bit of regression testing, but unit testing may or may not be in the cards in the future.
Okay, that's 9:15.
Okay, so we're Team Newman. Our coach is Christian Newman. Our sponsor is the E2 management system, so they're actually known as the Collaboration, which is a collection of 16 companies across various industries. I'm John O'Brien.
I'm Joe Dement. I'm Ryan Switzer.
I'm Dylan Voss.
You have to focus. Focus on the PowerPoint.
Oh my God.
There you go.
So we're going to talk about our project today and go over all of these details for you, our process, our architecture, give you a demo of what we have so far, and reflect on things that we need to do better and things we liked, and take some questions at the end. So for an overview of our application today, we had to synchronized with ISO standard 14001. So that's an environmental management standard that allows companies to measure their impacts to the environment and lays out a guideline for ways to adhere to that standard so they can reduce their impacts and make positive changes with their workflows. So the standard is a bunch of guidelines that allows companies to reduce their footprint and raises visibility from across the company. So everyone from the lowest level to the C-level executives can be knowledgeable in the activities involved with reducing their environmental impacts, and allows companies to know how they're impacting the environment, and specifically like what location on the plant or at the company that things need to be changed or fixed to further adhere to the standard in a positive way. And the standard presents the guideline in a way that is easy to understand, so you don't need to have any technical knowledge, and you can just know by looking at the application how good your company is at how low their impact is on the environment. So we have companies across the world, so we have thousands of companies applying for the standards so they can adhere to it and get a better, reduce their impact on the environment. We have 16 companies in the collaboration, so that's over the wide range of industries, from like banks and steel companies and car companies, things like that. So the idea of an eco-marker came around because that's how the companies collect their data. They have a CSV file right now, and they want to import that to a mobile application. And an eco-marker is a single data point that they can represent for an impact on the environment. And we need to we need to make this easy for them to reduce their impacts. So we're working towards that. So the dashboard itself, it has a series of requirements that we deduced through our first few weeks of interaction with our customer. It needs to be highly scalable because it has to be accessed from across the globe. It has to be widespread of coverage from all these industries, so it needs to be accessible to everyone with any level of technical knowledge. Consistent data because it's a standard and they need to have a way to compare results and see how things are moving forward. Needs to be have a universal user experience across mobile applications and the desktop so that things are easy to use and easy to understand.
So now you have some background context on our actual project and the ISO standard. I'm going to now go over the methodology we decided to use, elaborate more on the actual structure of it, and then dive into some of the details regarding our release schedule and some of our burn down charts. So to start off, the methodology we chose to use was Crystal Clear. Crystal Clear is an agile methodology which employs a continuous evolutionary delivery. So the system grows incrementally as we get new features with every release. It's very lightweight, flexible, and embraces a variance and requirements that may occur along the way, which is pretty standard to any agile methodology. The structure was pretty much refined from Kanban and Scrum in the sense that the tasks have the metrics of having story points, different priorities associated with them, and there would be time boxed with associated time for when we assume to be getting it done with. The pull system was used as a workflow for our different tasks that we had, meaning that we pull tasks in one at a time continuously throughout every release instead of doing a batch format, which pertains more to like sprints. What's very unique about Crystal is that we tailored the methodology more to the project rather than tailoring the project to the methodology. We found that Crystal's priorities also very closely align with our own priorities for the project, meaning that for priorities of efficiency, meaning that there was we minimized our waste, so we were staying focused on what was more important, so reducing overhead and the levels of planning that was necessary. Habitability, using a process that we were comfortable with using, so we would have one major meeting where we covered everything that we needed to for the week, and the other meeting would only be just like a checkup, see where everybody was at, and just verify that we're all on schedule. And safety, where we wanted to increase the probability of a successful delivery. So using a non-batch workflow where we were focusing on the actual task flow and not having stagnant tasks that were just sitting there in a work in progress, and we could actually get more transparency as to where things were. As for our releases, we didn't use sprints at all. We only used releases, eliminated the extra layer of planning and unnecessary overhead that we didn't really need. So more of a Kanban format where we focus on the flow of tasks, as I mentioned. Feedback per release guided our next release, providing feedback loop for more evolutionary delivery. So our workflow for a particular task is as follows. This workflow was used to emphasize task flow, as I mentioned, and prevent schedule slippage, and just create transparency as to where everybody was at. So the general format is, for every release, we would have tasks in this to-do bucket. And as one of us decided to pick off a task, we would then pull it into started, where we kind of mowed it over, got a general idea of what we needed to do for that task, and then once we were comfortable with what we were going to do, we then pull it into the in-development bucket, where we actually began implementation. Once we go forward with our implementation, once everything was taken care of, we would then pull it into the testing and review, where we would make unit tests. We would then do check on our performance and just review the ISO standard to make sure that everything conformed the way it was supposed to. If everything checked out and was hunky-dory, we would then pull it into our done bucket, where it was then ready to be reviewed, or ready to be merged and then deployed afterwards with our actual live system and the actual code base. Now our process per release is pretty generic agile structure. So we would follow a requirements elicitation followed by planning, building and deploying, releasing and improving to our sponsor, getting feedback, maybe having a feedback loop there where we would then go back and deploy more features that they may have wanted for us, and then finally repeating on it for the next iteration of releases. Now, because we are an initial startup, we wanted to really hit the ground running with a lot of things because, one, our project wasn't rolling over from the other, so we had a lot of design decisions that we needed to make, which we'll get on to in our later slides. So to really make sure that we hit the ground running more than anything, we use that walking skeleton type of format, meaning that we decompose the project's functionality into a single end-to-end function, which was like creating an eco marker, for instance. This really ultimately helped us establish a first piece of working and running software, and also really linked all the major architectural components together early on. So our UI to our API to our document storage. For our releases, there's really 3 levels of planning. Well, for the project in general, there's 3 levels of planning. There's the project plan altogether, our release plan, and then our weekly plan for every single week throughout our release. What really guided our elicitation early on was the ISO standard, because we all needed to be educated on it, and we really need to just understand it in general before we could actually begin any kind of implementation or requirements gathering. Once it was understood and we had a grasp on what it was that we were building, we then collaborated with our sponsor and derived some requirements from there. Now you have a general idea about our release development process. I'm going to now go over our release schedule. So our first release was scheduled for November 8th. It was the initial conception of the app. It consisted of our app UI, API, the document storage, image upload, CSV upload, and things of that nature. Right now we're on to our release 2, which is scheduled to be deployed for December 24th. Hopefully it will be much before then. But right now that's going to be consisting of our dashboard, which will have Google Map integration, multiple UI view options, searching and filtering of eco markers, and more granular functionality. Now come to the spring semester, we have 2 more releases planned. So for March 1st will be the deadline for our release 3, which is going to consist of users and authentication. We knew that this was going to be a big segment, so we wanted to make sure we allocate enough time for this entire different layers of functionality that was going to be required. And then come for release 4, which will be our last release, it was going to include more optimizations and gold plating what we needed to actually get done. Or, well, gold plating what we already had and establishing a more scalable solution, just refining anything else that needed to be fixed. Now you have an idea about our release schedule. We're going to take a look at our burn down chart and some of our metrics that we had. Now, our release periods were approximately 30 days. We allocated 54 total story points across 11 tasks. At the end, there was 1 task that slipped and rolled into our next release, into release 2 that is. That was approximately about 3 story points. Our cycle time per task was about 6 days, with some outliers that pertains, because obviously there were some tasks that may have been like 8 story points that may have taken us about 5 days to complete, and there may have been others that was only like 3 story points that we just got done in an afternoon. So there's a couple outliers there, but as you can see from the graph, we started off a little stagnant and slow, but as we got to the end of our release, we picked things up, and other than the 1 task that fell over, everything was pretty good. Now for our current release, the period was about 30 days again. We had 42 total points that were allocated initially, but with the rollover, there was 3 that were added. We had 10 tasks initially, plus the 1 that rolled over, as I mentioned. We currently don't know if there's going to be anything that's rolling over in the next sprint. However, things are looking good at this time. As you can see from our burn down chart, there is pretty much right on schedule, actually. And our cycle time has drastically improved from the last release. We're at about 4 days per task. And right now, we do not have any defects that we've observed. But hopefully, there won't be any.
Okay, so in this section, we're going to discuss our architecture and technology, as well as the rationale behind the decisions we made. So first off, this is a very high-level domain model of our system. As you can see, it's relatively simple. And a basic overview is that our dashboard displays organizations, and these organizations represent companies that are implementing the ISO 14001 standard. And these organizations have eco markers, as mentioned previously. We also prepared for potential different user roles based on different use cases. For example, one of these companies' shop floor workers might only need to be able to add a new eco marker, but management might want full access to the system.
All right, and going from there, we had to design an architecture that was very scalable, because a lot of things our clients want is we have to focus on that we could have tons of users, and we also decided to break things up into like separate tasks and stuff. So eco markers themselves have an image, so we need to facilitate a way for the client to upload an image, so we created an image service that handles uploading images. And another feature they wanted us to have was the ability to upload and parse their old CSV files into our database. So we created a CSV API that could facilitate for them uploading a CSV file and then mapping that CSV file to our data model. We also chose to use a GraphQL API for actually handling all of the data on the front end, so that way the front end can easily query for what data it wants and in what formats, because most of what our project is data visualization, so there's lots of ways to display our data, and GraphQL facilitates querying our data in different ways. We have a layer on top right now. This is a proxy load balancer that sits in front of all of our microservices, and we're using Docker, and we're specifically using a Docker service called Trafic for that, which handles scaling up containers and load balancing them all together. We also chose to use MongoDB for our data, and we'll get more into the decisions of why we chose to do that later. All right, so for our technology, for the front-end technology stack, we chose to use React, which is a component-based UI framework. Another team went into it earlier, but in case you missed that, React utilizes a virtual DOM, which allows the application to diff what is currently on the page with what you want to be rendered, and it efficiently creates updates for that. It's also component-based, which allows you to reuse different components in different places on the application. And it's easy to think about because it uses a JSS syntax, which is pretty much just HTML with a little bit of added JavaScript into it. For our backend API, we used GraphQL. GraphQL is a really cool new framework. It's not that new, it's like 2 years old. Implemented by Facebook. It's a query language for graph data. You don't have to use it to query graph data, so we're using it to query our eco markers. And the reason we chose to use this is because GraphQL focuses a lot on reducing the actual payload size of requests to and from the server and reducing the round trips from the client to the server. And we were really focusing on scalability of the technology choices we made, so that's why I chose to use GraphQL for our API.
We also chose to use Flask for actually implementing our APIs. Flask is just a lightweight web application framework that's implemented in Python. And then for our storage, we decided to use MongoDB, which is a flexible and well-supported document storage database.
All right, so for some of our front-end rationale and like why we chose these things, we chose to make a progressive web app for our entire application. Some of our requirements were that it had to look good on both mobile, it had to work on desktop, and they wanted it to be a seamless experience. So instead of creating a separate mobile application, we just created one web application that would scale down to a mobile app and would scale up to a desktop app and be a seamless experience for the users. We use GraphQL because, as I mentioned before, GraphQL scales pretty well with how users with how data works. So it reduces the request. And we chose React because React has a really good community around it. So there's lots of people out there that are really betting on React. So there's a huge community around React and like different components, and like a lot of code that we don't have to write, like a date picker and whatnot. It's all written already for us. It also has a great development community if you have questions about how the framework works. Same thing goes for GraphQL. There's a huge community building around GraphQL, so if you have any questions, you can ask forums and stuff about questions about that.
And more on the back-end side of things, our back-end technology really reflects some of the overarching concerns we had. When it comes to Flask, one of the primary reasons we chose it is that it is very lightweight. We build all our APIs from scratch, and this allows us to include only the dependencies that we need. This saves not only physical server resources, but it also makes managing dependencies and overall development a lot easier. And this is ultimately important because at the start of this project, we had immensely unclear requirements, and we didn't want to commit to a big monolithic system so early on. Instead, we wanted to be able to add features as quickly as possible when the sponsor decided that they wanted them, and the requirements became more well-defined. In addition, because we're using a microservice architecture, it just makes sense to use each microservice as a standalone Flask application, and this allows us to respond quickly to what the sponsors want by just implementing a new API and then calling it from the React front end. Lastly, Flask is written in Python, and our team has experience in Python, so this really mitigates the learning curve at the beginning of the project. And then for MongoDB, one of the primary reasons we decided to use Mongo was the structure of our eco markers. Eco markers themselves lend themselves very well to a document structure. Eco markers don't have any relations at all, and they simply hold data. Next, MongoDB is schemaless, so we can add properties to these eco markers whenever the sponsor wants them without having to worry about any database schema. This makes development quick and easy and really makes it easy for us to respond to change. Next is the performance. Our queries are all really simple. There's no joins necessary. It's just table lookups, and this is really good in MongoDB. And lastly is scaling. Our most common database operation, as I just mentioned, is just a large query on eco markers, which is a strength of Mongo, and playing to the strengths of our technology will ultimately help us scale. We won't have to fight the technology as we have a bigger load.
So at this point we were going to do a demo, but it looks like we ran out of time for that, so I think we're just going to move right on to the reflections about what we felt we could do better in the project.
So we had an issue at the beginning, or the middle of the semester. We had a team member in the hospital for a couple of days, so we had a bus factor risk. So we were easily able to mitigate that risk because we all had knowledge of Flask and the Python micro framework we were using. So it was very easy for us to move sideways and pick up the work that was necessary to stay on time and stay on track.
Another thing that we noticed, like looking back at like what we did, is one of the things we really want to focus on, just setting up where it's not like part of any of the releases, is a CI/CD pipeline. We ran into the issue of our sponsor really wanted the code to be in private repositories, so we couldn't use any of like the friendly open source CI/CD tools that exist. So we really didn't end up setting up much of anything. Currently, what it uses, we use Docker, and we use Docker Swarm to deploy it all. But when we push to GitHub, it doesn't automatically deploy, and that would really speed up our development process if we had that set up.
Another thing that we ran into is while using new and cool technologies can give you some really great features, it wasn't without its drawbacks. For example, we ran into multiple bugs with the GraphQL library we were using, with open issues that we just can't get around.
Yeah, one of the other issues that we initially picked up on was our metrics weren't exactly as informative as we were hoping. So like things like cycle time was a little bit miscued because obviously, as I mentioned before, some tasks were much bigger than other tasks. So there was outliers, and when we actually got the average cycle time down, it was not very accurate of how long it was taking us to complete any one task.
So now we have some time for some questions. Does anyone have any questions?
You guys have a super modern tech stack. It sounds like Mongo is exactly what you need for your use case. I'm curious, has using GraphQL, do you think that like significantly decreased your number of API calls?
So, yes. So using GraphQL, GraphQL is set up in a very strange way. So it has a client-side portion and a server-side portion, and the client-side portion is able to normalize your data during requests. And when it normalizes the data, it won't request fields on attributes that it already has. So if I'm requesting an eco marker with these fields, and I need these fields, it won't request the entire eco marker again. It'll just request the fields it needs to complete its internal model. So it has significantly, I wouldn't guess significantly increased the size. We don't have, the one feature that I think it's going to really help with is we have to implement like a map where they can view all the eco markers on a map. And we haven't implemented that, but that's where I think it'll really start to shine. Any other questions?
Are you concerned about trying to do, to build authentication and authorization after you have built your API?
So that was a very important thing that we thought about. So the reason we did it this way is because the development experience is much more nice when you don't have to worry about things like authentication and setting up your APIs. And since we're using a microservice architecture, what we end up doing is, when I showed you that architecture diagram, I don't have the portion in that we architected for the authentication service, but eventually what we hope to do is just create an authentication service that does OAuth with the front end, and then all the microservices will be able to ask the authentication service what level of authentication this person has. So we're not too worried about implementing authentication later.
All right. Hello, welcome to our senior project intern presentation. We are Team Kicking Butts, and we are working on a smoking cessation therapy platform. I'm Graham Holm, this is Holly Hastings, Austin Cohen, and Justin Haddock. So, on to the, I almost forgot. Our project sponsor is Dr. Joseph Bashnagle, and our project coach is Cal Rabb. The problem at hand. Smoking is the #1 cause of preventable death in the United States today. Despite extensive education efforts, 17% of the US population still smokes cigarettes. Compounding this problem is the fact that 85% of smokers who attempt to quit using therapy or medication fail within the first 6 months. Cognitive behavioral therapy, or CBT, is one promising approach to behavior modification. It emphasizes analysis of and awareness of one's own thought patterns in an attempt to retrain specific behaviors. However, like many forms of therapy, CBT also relies heavily on self-accountability and self-reporting. For example, patients typically only see their therapist once a week, but they may have the urge to smoke several times throughout a day. There is a clear need for a platform to support people using CBT. Patients need support during their treatment. Therapists need to be able to customize this support to fit their specific therapeutic goals. And people who are researching CBT need to be able to collect data on how efficacious certain procedures are or are not. This sort of solution has to be accessible to all users, whether they're patients, therapists, or researchers. It has to be secure. It has to securely transmit and protect patient data so it doesn't get into the wrong hands. And finally, it has to be extensible. The goal of such a platform would be that it could be used for any sort of CBT application, not just smoking cessation.
So this is our solution. We created a CBT assistance program. It involves 3 main parts. One is a mobile application, which involves behavior tracking, just-in-time interventions, and data collection, including location and time, to try to figure out people's triggers for certain behaviors. We have the web application that allows researchers and clinicians to be able to configure the mobile application for different user groups. They can also view collected data from the app users, and they will be able to create and deploy their own intervention strategies. And we have the database and the API which connects those two.
So as far as requirement solicitation goes, the first strategy we kind of used when we first got this project was just based off of the document that we were given from our sponsor, just going through, looking through the requirements and trying to turn those into user stories. We also had the previous teams that worked on this project, their requirements document that we went through, and we were able to get some of the base Android requirements that we wanted to go for. But most all of the requirements that we came up with were just based off of kind of interviewing our sponsor, having Q&A sessions with him. We would ask him just questions, and based on his answers, we would try to translate those into user stories. When we didn't meet with him, we used brainstorming to just kind of come up with our own ideas that we wanted to implement into the project, and when we met with him, we would present those and get his feedback to see if he wanted those turned into user stories or not. As far as refining our requirements for the UI, that came through just prototyping and demoing our product, both the web app and the Android app. We were able to demonstrate those to our sponsor and kind of get his feedback and how it looked and just the interactions that it went through to further refine our requirements for that.
Alright, so for the web application design, we decided to go with Angular 166. This is because that's the one that we had the most experience with, and we didn't have much experience with the 2.0. Routing within Angular is dependent on account type, so when a user logs in, it will send back a numerical value of what kind of account they have. We have multiple different types of accounts that we'll go over later in the presentation. And every page has a controller, which is nice for keeping things separate, and multiple people can work on the same project at the same time and not worry too much about conflicts. And we've also utilized Gulp to streamline development, and it's just a tool to kind of take care of more of the manual tasks in file concatenation. And it creates a folder that is real nice to distribute when the project has a safe release.
All right. So, on to design. For the Android app, the design strategy is pretty straightforward. Take user stories and convert them into Android activities. So if you don't know, an Android activity is a screen or a sequence of screens with input and output controls so the user can interact with the app and achieve goals. Some of the design considerations we had to take into the account for the application, the big one was network connectivity. As we all know, network connectivity can be spotty, but at the same time, the user always has to be able to use this app. They might have the urge to smoke any time, and it's really important they be able to pull out the app and receive an intervention or log a smoking activity if that occurred. So, in order to accommodate this, we enable the app to work offline by simply fetching and storing data locally when it needs to, when there's no network connectivity, and then syncing that data with the database when network connectivity is restored. We also had to find a balance between the trade-offs of security and accessibility. We need to protect the user's data, but we also need them to be able to start using the app quickly. They may not always have time to sign in. So in order to accomplish that, we designated specific tasks, critical tasks, as okay to use without signing in. For example, logging a smoking activity. You can always pull the app out and enter that information without having to sign in. But if you're going back to look at your smoking events, for example, at that point you have to sign in. So in that way we made critical tasks easily accessible while still protecting private confidential data.
So for the design of the database and API, the backend, we eventually decided on using a LAMP stack, which is Linux, Apache, MySQL, and PHP being the RESTful API.
The main thing we had to focus on when trying to decide how we wanted to design the database, or the database tables themselves, were we knew there had to be different roles within the system for users. So there's 4 main different roles that we have right now, and the way that's set up is we have a different table for each one, and they all link up to a higher table, which is just the users in general. In the future, we plan on adding just a privileges table. That doesn't exist right now. One of the things that we had to consider when designing this was the HIPAA requirements. And a lot of those have to do with the security, and we've tried to design it in a way where it's going to be easy to implement those features in the future. A lot of those are security oriented. We've looked into implementing them, but they're not completely there yet. We know once we get to that point, one of the trade-offs is going to be responsiveness versus how much security we implement. We don't expect just like the base security practices to impact performance at all, but in case we go overboard, we realize that's there, such as API keys and encrypting passwords. That's all we really plan on implementing, which shouldn't have much effect on performance.
And here's just a base graph of the users tables. The horizontal ones in the middle are the 4 user types that we have, with the users above it. And then the bottom 2 tables are just specific to the few types of user accounts.
So for our implementation strategy, we decided to assign roles on our teams based on each other's experience and interests in the different parts of the project. We made sure to work on complementary features at the same time. So if one of us was working on account creation, we all were. We tried to use technologies we were already familiar with, the exception being Android. None of us have had any experience with Android, but Graham knows Java, and he was very brave and decided to be our Android guy. We chose technologies based on non-functional requirements. We're going to talk about more of how we chose our database later. And we wanted to have isolated code repositories.
Okay. For the web application, some of the implementation trade-offs we took is we're using an older version of Angular because it was a solid release. We have experience with it, and we have several plugins we knew worked with Angular 1.6 we wanted to use. And it has easy data manipulation. I happen to be a big fan of Angular's HTTP, how it works. For the design of the web app, we were using SCSS, which is sassy CSS, because it has a little bit more capabilities than regular CSS, such as variables, which are really nice. For the color scheme of the app, since none of us are designers and it may change at any moment, it's nice to use variables so that when one is changed, the whole look of the application is changed and updated. Gulp was used to streamline workflow and do a lot of more like grunt tasks for development. And one of these examples is turning our SCSS files into CSS and concatenating all of them into one big mega file. So on the index page, you only have to import one CSS file. And there's just other things like that. And one of the big parts of this application is there's a survey that the smokers that use the Android app will fill out about their history and how they smoke, and medical questions that need to be customized by researchers and clinicians for their patients on the web app side. And we looked into many different packages and plugins to use for creating a form, but they all either required so many requirements that they kind of took over the application, or they were just being tedious, so we decided to just make it from scratch. And this way we can really know that it's what we want and that it's going to be HIPAA compliant, because we can build it to be secure that way.
So when we were first looking at how to implement our backend, we were trying to compare if we wanted to set it up locally or use a cloud-based system. We eventually decided on going the cloud-based route. We found something called Firebase, which looked perfect for what we wanted to do, and it would reduce a lot of the overhead that we would have had. So we started working on that and developing with Firebase as our backend, and then a few days later we realized HIPAA does not allow for cloud-based web apps. So we had to pretty much wipe everything that we had and had to look into local tech stacks. We looked into tech stacks that have been known to work well together. So the main two we looked at were just LAMP and Mean.
We eventually decided on going with LAMP just based on the nature of the application in general. It's a health-based app, and the database is going to have to be rigid for what we need it for. So that was the big decision between going for a SQL and a non-SQL kind of stack. And then within the LAMP stack, once we had decided on that, we had to choose if we wanted to do Python or PHP for the API, and we eventually just went with PHP. One, because that's what I'm more familiar with, and I was designated as the backend kind of guy. And based on the research we did, it seemed like PHP worked with Android a lot better than Python.
All right, so testing. We have we feel a good testing strategy. Of course, we have unit tests for all of our subsystems, and we run these unit tests before every commit. All unit tests is a form of regression testing to make sure we haven't broken any new features. At the same time, we add new unit tests with every new feature, of course, to make sure it's working as expected. We also do integration testing using Jenkins to test interoperability between the Android app and the API and the web app and the API at every commit. We do usability testing on the user interfaces of our web app and Android app using the usability heuristics checklist, which were actually given by our sponsor, so that was very helpful. We plan to implement security testing as soon as our security requirements have been implemented, or as they're being implemented, to meet HIPAA compliance.
So for our methodology, we decided to use Scrum because while our requirements have been fairly stable, we wanted to maintain as much agility as possible and produce value to our sponsor as soon as we could. For stand-ups, we do have stand-up meetings every day. We have a bot in Slack that bothers us and tells us to do our stand-up meetings. And when we meet in person, we do actual stand-up meetings. We keep track of all of our product and sprint backlogs on our Trello board. And every 2 Sundays, we meet to focus on sprint planning and retrospectives. We also had to add a little bit more documentation, usually more than Scrum has, because of how important HIPAA requirements are. And we created a lean testing plan because we haven't really been following test-driven development, so we kind of needed more documentation to compensate for that.
So for our risk management process, really most of the defined actions were just kind of verbal discussions that we had during when we were creating our 4-ups. We stated what the risks were that we foresaw, and we just kind of verbally talked about how we would handle them if they came up. So we're planning to create a more thorough document in the future to define like the calculated risk exposure on how to prioritize those risks, because we didn't really have a prioritization method from what we've done so far, which is the impact that it would have times the probability, and also have written defined actions and who is going to act on that if a risk does come up. As Holly touched on, one of the nice things with Scrum is that it allows us to kind of avoid some of the potential risks that other methodologies might have. For example, if we misestimated on some of our story points, we took on too much work or too little work, we meet every 2 weeks, so that helps us to reorganize everything in a quick fashion. One of the risks we ran into that we didn't account for was our VM got shut off that our database was hosted on. It's happened twice so far, and he didn't let us know that it got shut off. The people testing their apps just thought their apps were broken and they were doing debugging until we realized that it was just our VM that was shut off. So now we have an action in place that we ping it every day to continuously check that it's up, and we've taken as much work as we can to make sure that doesn't happen again.
Who's first on results? I don't know. What is it? Go for it. Oh, here we go. The Android app. So we're in the results section, as you can see. This is a snapshot of what we've got developed for what we have developed for the Android app so far. So here on the right, you can see our welcome screen. It's got a little overview of what the app will do for you, which was graciously provided by our sponsor. In the middle, you can see the part of the account creation process. So we have this account creation and login activity where all form fields are validated as they're entered. And then on the extreme left, we've got a terms and conditions activity. Again, the terms and conditions were provided by our sponsor. And
the user must agree to these terms and conditions before they continue using the app. Basic legal disclaimer stuff. We wanted to make sure the user read the terms and conditions, so we cleverly placed a tiny checkbox at the very, very bottom, so they have to scroll all the way through them to check that before they can continue. We hope in this way they will at least have skimmed the terms and conditions before they begin using the app. We've defined a card-style UI for our application with high contrast text and highly visible buttons and inputs which appear in consistent locations across activities. And we've designed our UI to be responsive so that, and we're testing it on a variety of devices, so that no matter what your screen size or resolution or aspect ratio is, the content will lay itself out in a way that makes sense and works for you.
Okay, here's some snapshots of the web application. Right now we have the login form and account requests. So we have three main types of accounts on the web application. There's the admin, which is overseeing and can do most of everything. And then there are researchers and clinicians. Researchers and clinicians have some separate things they can access based on like the data they can view and what they can implement for customizing the Android application. But so far we have fields for logging in, survey creation, account requests, and for when a researcher or clinician does request an account, they have to get approval from an admin before the account actually becomes activated. And we have that screen on the right there that shows some examples of that.
So I don't have any nice visuals of our database, but what is in place is all the routes for account creation. There's separate routes for creating each of the 4 different types of accounts, and there's also a login function for each of the accounts, which pretty much just checks if the username exists, if the passwords match up, and then it just sends back a true and false right now.
So just to recap our current project status, we have completed account creation and login capabilities. We've started to standardize our UI. We've created portals for admins, clinicians, researchers, and we've started working on creating surveys. Let's look at our metrics.
All right, so one of our process metrics is we recorded time in Toggle, and Toggle's nice because you can input what you were working on and specifically like meeting, testing, UI, database, whatnot. And these are our cumulatives from our whole group. The first sprints, we were really just kind of getting into things and not sure how our footing was. We had a little bit less work there that we made up for in the second sprint by having the most time committed so far. And we've been rather holding steady, and as we've got our groove, we've had less time required to throw into it because we've gotten some of the development practices down. Here we can see our velocity. As sprint 1, we estimated our story points very poorly. I would say we got much better at that as practice and time went on. And you can see we're getting better at hitting our velocity goals and trying to have our amount of story points we have planned match or completed. And we hope to see this trend continue and hope to see the tolerance between completed and subscribed to keep going down. Lastly, we have our burn down charts, and these are all for 4 weeks. You can see we have been getting better over time, which is what we'd like to see. Each sprint that goes by gets a little bit better looking burn down chart, and we hope to continue this trend in the future.
Yeah, one of our product metrics was lines of code. Our first sprint was much higher than the other ones, and that's what we expected just based off of frameworks and skeletons that we brought into the project and push, but it's been consistent since then. And we're going to go ahead because we're out of time here. We just want to skip these.
Absolutely. All right, I'll just touch upon these really fast. I mean, we learned a lot of great stuff about this project so far. I'll just touch on some of the most important ones. Story points. They gotta have a meaningful basis in reality. Initially, they didn't. We just sort of assigned them, and that made it really hard to know how many user stories we could actually take on in the sprint. So we quickly learned to assign story points based on estimated person hours. We also learned to break down our user stories into smaller, discrete tasks, as small and granular as possible, because those small tasks, it's really easy, comparatively easy, to estimate the effort required accurately and how much time it's going to take to complete it. And then you can just sum those up to get the story points for the entire user story. That was great, and it helped us have more realistic sprint planning. Once we learned to figure out how much time we would actually be able to work on the project each sprint, we could take an amount of user stories that matched up to that pretty closely in terms of the time it would take to complete. Developing complementary features. works really well because we're all supporting each other and we can deliver really robust functionality at the end of a sprint. We've all worked on the login functionality feature together, so the whole thing works seamlessly across the system at the end of the sprint. Specializing in specific roles, which is what we decided to do, has advantages, such as, for example, we can all focus on learning one particular skill set, but it's got some disadvantages. You can't really turn to your coworkers and ask for help, your teammates and ask for help if you need it, because they're not working on the same thing as you, and they probably don't know that technology, so you have to go Stack Overflow.
So our plans for next semester, we're wanting to finish survey creation. Right now it's not connected to the database. We got to get that done. Smoke tracking in the Android application requires a lot of little mini things that we need to worry about, such as location-based things and implementing that after the fact. And data display and exporting for the web application for medical research. Do you all have questions?
Yes?
So why Android?
Android, I think that was a request to our sponsor.
Yeah, it was a requirement. The sponsor required it to be an Android application. And
He
so
has an
it is.
Android phone, so it makes it useful because we can just send the app to him and he can demo it out and let us know what he thinks. Yes?
So was there any pushback on that? So none of you have experience with that, but it sounds like you have experience making web applications, and it seems like you sort of set web application for Android. Did you push on that requirement at all, or was that pretty fixed?
Right. Well, we knew high availability was a concern, and so, none of us have experience with web apps either, but since high availability was a concern, we really wanted a local application that could be used at any time and not have to rely on a web application, for example. Yeah.
Are there any Android services that are required to make the application run? Or would a web app work? In other words, do you need location or an Android service?
That's true, yeah, and I think some of those are accessible through web apps now. I know they're getting much more robust every day, but we knew that we could definitely depend on them being there if we had a local application. So yeah, we are going to use geolocation and things of that nature.
Also piggybacking off that, earlier we said that we need them to be able to collect data from users at any point in time, and that requires accessing the application when there's no network connection. And if you have a web application, you have required to pull things down to access content, then that could possibly be an issue.
Have you ever considered multi-platform mobile development frameworks like Vector or React Native?
Yes, we did. We know that's definitely an approach some groups take. But given that I had a lot of experience with Java, I figured it would just be easier to get the ball rolling and just programming it for Android. And we'll worry about cross-platform deployment at a later date, if at all. So.
All right. Hello. We are Team Gallerat, and we're creating a cyber advisor web application for Gallerat. They're a cost estimation firm. I'm Joshua Shear.
I'm Joe. I'm Ian Dansera. I'm Nathan Evans. So for our team, besides all of us having development roles, we also assigned other roles. I'm the Scrum Master, We have Joshua as a product owner, Nathan is our team website manager, Joe is our meeting scribe, our project sponsor is Lee Fishman of Galarath, and our faculty coach is CalRab. So, Cyber Advisor is an online web application which will analyze the status of their current cybersecurity and provide recommendations on how they can improve it. The users can be homeowners, small businesses, or enterprises. It'll work by having a survey that the user will fill out, and that survey can spawn extra questions depending on the results, and then it will generate recommendations based off of the user's input that the user can then use as recommendations. The user can skip any question they want and go through in any order, but the more questions they fill out and the more specific they are, the better the recommendations will be. Once they get their list of results, they're allowed to filter them, sort them, remove them, do whatever they want with them. So when we started the project, there's really undefined scope and requirements. So we knew one of our biggest problems was going to be figuring out how we're going to, what the problem was, and identifying it, and how we wanted to solve it. So we decided to break it up into two parts. We had the actual user interface, and then we knew the algorithm which we would use to map the survey questions to the actual recommendations. And we're referring to the algorithm as the recommendation mapping algorithm. For the user interface, our first goal was for it to be highly usable. We wanted to make sure that it was very clear what was going on and how you could actually use the application. And then our second goal was to actually implement the algorithm itself. So for our process, since we had poorly defined scope and requirements, we decided to go with an iterative process. We started off with Sprint 0. That Sprint 0 was used just for initial requirements gathering. Since we didn't really know the scope and the requirements, we really wanted to have something solid to work off of for future sprints. So once we had our requirements kind of set and the scope set down, then we decided to do 3-week sprints. Each 3-week sprint follows a modified Scrum process, which we'll go into in the slide after this. So for each one of our 3-week sprints for modified Scrum, what we do is we follow a process where we have sprint planning at the beginning. During sprint planning, what we'll do is we use Trello. We take all of our requirements, we put them into our product backlog, and then we use planning poker with physical planning poker cards, and we estimate the relative effort of each task in the product backlog. Then what we do is, based off of our estimated how much work we can handle per sprint, we then move those tasks into our sprint backlog, and we assign them to team members based off of their skills and what we think are the highest priority tasks. We meet 3 times a week. On our first meeting of the week, we do a weekly stand-up. We fill out a 4-up, and we talk about what progress we've made, what we're working on, and any issues we're having or things that are blocking us. At the end of every sprint, we have a sprint retrospective. We talk about what we can do better for next sprint, what went really well and what we should continue doing, and anything we want to change in the future. Lastly, our sponsor has an Azure server that we use, and we're storing everything on GitHub. So what we do is, at the end of every sprint, we take the latest from master, we deploy it up to the Azure server, and we have it as a deliverable for the sponsor to test. As my role as a Scrum Master, I'm keeping track of our team's hours. So this is just a graph of our hours inside of meetings and then our hours outside of the meetings and the work we're doing there. As you can see at the beginning of the project, I mean, it took some time to ramp up and get us into a group. Then we evened out a little bit in the team meeting hours, and then our outside of meeting work increased the entire time. We eventually realized that we need to do most of our work outside the meetings, so that's where you can see that increased more, and our inside meeting time went down. And then as we approached the holidays, it kind of went down a little bit.
All right, in addition to the time tracking metrics required by the department, we wanted to identify valuable requirements that would contribute to the success of the project. We followed the goals question metrics model, identifying the goals that we wanted the application to accomplish, the questions that verify that those goals were being met, and then the metrics that are the answers to those questions. We came up with 3 process metrics, starting with velocity. It's easily derived from our burn down chart as part of using the modified Scrum. This visual is our sprint 2, or our first development sprint burn down chart. The second metric is rework. We define that as any user story that's marked as completed and then needs to be fixed in a later sprint. So it doesn't refer to, or it doesn't keep track of regular changes to the requirements. Our third process metric is development time. We're using T-metric, which allows us to delineate how our time is being spent. So in addition to the graph previous, we're able to track specifically time spent on development. Our singular product metric is the SUMI score, which relates to usability. It's an evaluation that a tester will fill out after using the application, and we plan to do that as part of our usability testing down the line. So as Ian said, our Sprint 0 was focused on prototyping UI. We decided to follow the 444 curriculum, defining our 3 work roles: the homeowner, the small business, and a large business, understanding that our users will be a representative of one of those entities. We created a workflow model, which is very simple, and you just fill out the survey and then navigate to the results. We created work activity notes with an eye towards using those as our requirements down the line. You can see them here in our work activity affinity diagram, which we created to see the different sections of our work activity notes. We created a hierarchical task analysis. It's a more in-depth workflow model, similar to a use case that just has alternative flows, and our plan is to use that as the map for usability testing down the line. From there, we felt we understood what we needed out of the UI and created individual design sketches. We reconvened and went over those together in order to see what was good and what was bad in order to create individual wireframes. We went over these with our sponsor in order to understand what he needed from the UI, and we created a detailed design from those notes. The detailed design represented our sort of a graphical requirements of how for our UI. We ran into an issue where the work activity notes didn't work as user stories. We had them in a spreadsheet, and when it came time to actually do the work, realized they didn't translate into functional requirements, so we scrapped that backlog, moved to Trello, and went back to the detailed design to come up with user stories more similar to what we're familiar with. Another area of improvement, we found that early on we were discussing both process and product considerations with our sponsor during the meetings, and this led to long meeting times and a certain level of thrashing, so now we focus on only product items in our short and valuable time with the sponsor. Additionally, in our first development sprint, we found that we were assigning user stories based on the estimated relative effort instead of the different skill sets that we have on the team. There's different facets of the application, the database, there's a network communication, there's a C# backend, and a web front end. And now that we've been working together and are more familiar with our skills, we're able to assign user stories based on what people want to be doing. Additionally, we have no budget, so it was difficult to get our remote computing resources together, and Josh will go into that a little bit later. Last issue we ran into, we had established that we wanted to do pair programming, but have yet to do so. We have the pull requests, code review, testing set up through our repo, but going forward we're recommitting to pair programming as we start on the recommendation mapping algorithm so that every team member understands how it works and is able to take ownership of that. To talk about some of our risk management, every week during the 4UP, we are enumerating our risks and then moving them into our formal risk register. Here is sort of our cone of uncertainty, where the X's represent risks that we identified but have yet to realize. The check marks show risks that have impacted us or have been mitigated. It sort of follows how when the project wasn't as well defined, we had fewer risks, and then we came to fully understand what was required of us. and the risks ballooned. And then we found the best mitigation was to just do the work. So as we had the database set up, as the UI functionality is completed, we're able to get the tapering off going into next semester.
All right, so for the technologies we use, when we were trying to figure out how we were going to accomplish the project, we had the option to use Iron, Python, and C#. And our decision was, instead of mixing Python and C#, to just go with one of them, and we chose C#, specifically with ASP.NET. And this allows us to use Visual Studio, which has the MVC framework, which was very easy to set up and allows good communication between the front and back end, as well as our database. And Visual Studio also gives very good unit testing support that we will be taking advantage of a lot with the algorithm, making sure that it works as expected every time. For the front end, we're using Bootstrap to make it look pretty, and we still haven't customized it yet, so the site currently looks very bootstrappy, but we plan on customizing it in later iterations to fix that. And the database that we're using is SQL Server Express. We chose this instead of SQL Server because SQL Server Express is essentially the same thing, and as long as you stay under 4 gigabytes in total database size, you don't have to pay for it. And our database is currently quite small. We don't expect it to grow anywhere close to a gigabyte, let alone 4 gigabytes. Speaking of the database, it took us a while to figure out how to properly set up the database. Initially, when I set it up, we each had our own copy of the database on each of our development machines, which means that anytime one of us wanted to update the database schema or the entries in the database, all of us would have to pull those changes and apply those updates to make sure we weren't having errors and we were all looking at the same data. And while this worked, it wasn't very convenient. And so we went to the SE department to get a VM for running a SQL Server Express database. And we got the server, we got it set up with the database, and we couldn't connect to it. So we did some troubleshooting, and we found that if you aren't on the RIT network, it will block the port that SQL Server uses from going out to other networks. So we brainstormed several solutions and ultimately chose to go with an Azure instance, which, so long as we don't go over 35,000 database transaction units, is free. We're currently at about 15, so we don't think we're going to be going over during this project. In terms of our UI, Joe already went over how the process behind developing our UI, but our big focus was on usability, because not everybody that's using this web application will be as tech savvy as those of us here. They might have a computer and know that I'm vulnerable to a virus, but I'm not sure how, and I want to protect against that, and they'll use this web app to figure out how. We want to make sure that they're able to navigate it and understand how to use it. So we put a lot of thought into making sure that survey questions were very easy to find and that results were easy to filter and sort.
So here's a screenshot of what the actual survey page looks like. And like Josh was saying with the UI and usability, what we wanted to make sure the user had was that they could go where they needed to go, see what they wanted to see, and know what they needed to know in order to complete the survey, because they're not all going to be technology savvy. So as you can see, the actual questions are collapsible to allow the user to have more space, so the questions aren't like overwhelming the page, because each question can spawn new questions depending on the answers, and that can grow very quickly. And that's also why we tabulated the survey and broke the questions into sections based on
what kind of user we have and what kind of questions are being used. And then there's the navigation section off to the left to let them jump to whatever question they want to go to at the time. And like we said before, questions can be skipped in the event that the user just doesn't have the information at the time, or they already answered it, or for whatever reason they just don't want to deal with that question at this time. It can be skipped and they can move forward. And a part of their ability to come back is through the import and export functionality that we have. So the idea is that the user can export their progress so far with all the questions and all of the recommendations that have been generated, and they can import it back if they want to come back and start from where they left off. And what we have here is the results page. There will be filters. I know it's blank now, but we're working on it. Similar to the questions, the recommendations are also collapsible, and what the recommendation sections show are a short blurb about what the recommendation is, the threats that are assessed by the recommendation, and our rationale for choosing it. That way, if the user, for some reason, has a solution that we just don't have in our database, they can make the conscious decision to ignore that recommendation. And at the same time, it does work with our intention of educating the less technologically savvy users in their attempts to defend themselves. So a lot of what we've been doing this semester, including the UI, has been laying the groundwork for actually implementing the recommendation matching algorithm. It's still in the planning stages. We did a lot of research and wrote a short white paper on it. One of the most integrated parts right now is the database, which is going to be tightly coupled to it. So that's going to change a lot as the algorithm evolves. And our hopes and plans are that it will be deterministic. That way, users who come back will be guaranteed the same results as if they only completed the survey once. And it will also help in testing to make sure that we're getting similar results as the algorithm evolves. And that's much of what the import and export functionality is for as well, to help replicate the idea of different users entering the same thing or the same user coming back more than once. Any questions?
Yep. Is it a requirement that the client be able to change the actual content of the survey in case it becomes like outdated or they find it's not effective?
The questions are in the database, so they will be able to do that as they see fit.
Do they have a UI or some sort of?
No, our sponsor is pretty technologically savvy, so he is able to access the database and make those changes himself.
Gotcha.
Yep.
Oh.
Why did you decide to go with an export-import instead of saving the user's state?
We decided to do this because it comes down to the amount of space we want to be taking up on whatever server's running it, and also security concerns. Because it would be storing, if we went with a saving option, because it would be storing a lot of people's and companies' essentially vulnerability list, it could be a very potent target to hack. And if that were compromised, you'd be giving away lots of vulnerabilities for lots of different companies and businesses and people. And so we felt that if we don't save that information, it's a lot less likely it'll be stolen. And having it export, they store it themselves and they're responsible for securing it, and they can protect it how they want to.
It also assists with testing. We're able to.
Yeah, that too. It definitely does help with testing, because we can fill out the survey once and export it, and then with our testing, we can just import those results back in, and we have the same set of answers on the same set of questions every time, and make sure that we're getting the right outputs in the results based on that.
Can you talk a little bit about your testing framework?
So Visual Studio has built-in unit testing so that you can create a unit testing project in the the solution that you're working in. It's a bit of a weird naming scheme. This whole project is a solution in Visual Studio, and then there are individual projects within that, one of them being the web application, another one being the database, and the third one being the unit testing project. And within there, you can create unit test files that will have a bunch of unit tests in them. And then when you want to run them, it's as simple as hitting Control-RA. And it will run all the unit tests, and it will show you which ones passed and which ones failed and why the ones that failed failed. And you can even debug within running those tests to see where it's failing in your code.
Do you have any client-side applications or any need for that? For example, to look for holes in the firewall or sort of any active monitoring?
That's currently out of scope. Yeah.
Have you guys tried using the RIT VPN to access the server from outside of the network?
No, we haven't. I wasn't aware of that. I don't know if anyone else on the team was. Yeah, we have a solution now, but yeah, I suppose that would have been nice to know.
All right, thank you.
Well, hello everybody. We are Team Meteor, and our project is the floor plan room selection for StarRes. So, quick outline of what we're going to be going over. We're going to be going over quick introduction of like what's the problem in domain, what application are we creating. Then we're going to step through our process to how we're going to be a disciplined way of solving this solution. Then we're going to be going over requirements and design, what it needs to do and how is it going to look. Then we're going to go over what we have now and what we plan on doing next term. So room selection is a very stressful time for a lot of students. There's a lot of considerations you take into account. Can I afford it? Is it near my class? Can I even get to this floor? And this stress can kind of evaluate to a lot of very negative consequences. Students will skip classes. I'm sure we've all done it. We've skipped classes just to make sure we get the right room that we want. And that they spend a lot more time on it. And a lot of the software now, applications now, is kind of hard to choose quickly what room you want to select. Luckily, StarRes exists to try to make this process as quick and easy as possible. And this application is just kind of the next step in their goal. So what we are going to do is taking what they currently have, which is a lot of cards that kind of show where the buildings are, and convert it to something that you'll see on an airline, where you're able to have a nice top-down overview of where everything is, and just with a quick glance you can see what's available, what's not, where it is in relation to the rest of the plane, and what attributes there are on this seats, except we're converting this to rooms on in an apartment. So it's important to note that before we start the rest of this is that this is more of a proof of concept for StarRes. This is not something that we ourselves are building and then integrating into their system. This is something that we are building to try to prove that the technology exists and that this experience is something that's very viable for them to use, that they will then break down, reverse engineer, and put into their own system. So what this means is that they gave us some test data to emulate their system as close as possible, but we're not really worried about some of the finer aspects of this application. Namely, we're not worried about user counts. We're not worried about their existence. We're not worried about creating them. And we're not worried about the security of these accounts whatsoever, since this is test data that we're not worried about losing. And this is not something that ourselves is going to be used in their system. This is something they're going to break down and use in their own constraints and their own requirements. So since this is also something we're trying to emulate their system as close as possible, we want to make sure our technology tries to mirror that as well. This means we need to make use of ASP.NET, we need to make use of MVC, we need to make use of the entity framework, and we're going to be using some JavaScript stuff. However, since this is also something we're trying to improve, we can use whatever technology we need to that helps further the goal of allowing selecting rooms and for a better user experience. That means we're going to be using some Fabric and Canvas, which we'll get into later, as well as some EMG CV, which again we'll get into later. We're also going to be making use of Trello and Slack mostly for our own processing.
Let's talk about our technical process. What did we decide to do for our process? We chose the Scrum framework. And why did we choose this framework? From the beginning, we prefer an iterative and more agile approach. It has less ceremony, but it still keeps everyone in the loop. Even though we're working with an existing system, just a reminder, our sponsors are looking for a proof of concept or a separate app that they can integrate into their system later on. That's why they want high visibility, high project visibility, and therefore we chose this Scrum process. What we want to happen during the development are the three things listed above. We want frequent status updates, and we want smaller size features so that we can be responsive to change. Finally, we need team consensus to ensure that we have software integrity. So what is the process like? Well, so what we're doing is spending 2 weeks for a sprint, and twice every week we conduct stand-ups where we discuss our progress, our plans, and our blockers. Because it's tough to align everyone's schedule, we can't follow something like daily Scrum, so we modified the Scrum framework to conduct online stand-ups semi-formally through Slack channel. So for metrics, we used story points. In Trello, we implement a Kanban model where we split checklists into 3 different categories. We have the product backlog as the to-do list, our current sprint as doing, and the previous sprints as the done category. Each checklist item in those lists has a story point representing its complexity, and we assign those points item through our team consensus game called Planning Poker. And as a result, we can measure relatively well how much we can do for the next sprint based on our velocity. We also installed the Scrum for Trello plugin of Chrome to display those points. And the plugin also generates a burn down chart to let us monitor the overall trend and what happened during a previous sprint when we carry out our sprint review.
So we've got just a couple steps before any change can be actually committed to the repo. Before, when someone actually makes a change or does anything, they have to make a pull request, obviously, and 2 developers need to then review said request. Then they need to make sure that the original person who made the pull request needs to make sure that all of the Jenkins integrated testing actually are still passing, and to include any new unit tests if they actually added more functionality.
Now I'll go over our requirements. For this project, we have 2 user groups, students and admins. Our students are mainly just college students. We think of them to be somewhat tech savvy. They like to get things done quickly. And our admins have the potential to be less tech savvy, but we assume they also would like to get this process done as soon as possible, or as fast as possible. So we try to keep that in mind when we are implementing these requirements. Our students must have the ability to view floor plans, filter rooms, assign themselves to a room, as well as assign their roommates to a room if they want to. In addition to that, they can view each individual room's details. These details are things like the room availability or the room size. And then our admin users must have the ability to add floor plans, manage floor plans, and draw on the floor plans. What I mean by draw on the floor plans is we'll be giving the user an image of a floor plan, and from that they'll be able to select where on the floor plan each specific room is, and then they can label them so we can use them later for displaying it to the students.
So Stars gave us this is their design they have right now for their room select. It's pretty simple. With, just, as you can see, just a standard filter sidebar and all the buildings clearly listed. But these images aren't very helpful if you're trying to decide what kind of what room you want. That's why we have this. We made this mock-up of the design, which is basically each building shows each floor and all the available room that the user is eligible for, either through requirement, either through if that floor actually allows them to be in that, or any filters that they have active, it'll gray out the ones that they're not eligible for anymore. Then they click the floors of throughout the layout, which like this, which is an example of one of the layouts. Then they just click on the rooms if they want to select a room. All right, so now that we know what our users are, what they need to do, and kind of a general idea of how they're going to do it, we kind of need to show how having an architecture or software architecture kind of facilitates that. So ASP.NET MVC, obviously a very standard MVC pattern, not really a whole lot to go into as opposed to an MVC. However, we do have our own little stipulations that help us as developers out. This is our current little architecture. What we have, 2 main things is, since the entry framework creates a bunch of models based off of the data it's currently in the database, that then gives us a database context we can then use to add, remove, and grab any information we want from it. However, we wanted an additional granularity, so we kind of added a different layer and abstraction on that as well, which we use as a database access. What this does is we have this interface that we all use implement on the left to give us something like entries, floor plans, rooms, buildings, and then any controller that needs it, we inject it with a dependency injection at runtime to be able to grab whatever information it needs, and this helps us so that we know controllers being able to grab everything at once. We also have this grabbed a little bit from the model view model book, in which we have a nice view model at the bottom, since not all of the models that are from the database are packaged in a way that's very easy to display or in a way we want to display. So we can use our database access objects to grab information, throw it into a view model, throw that to the view, and the view can display that however it wants. So an example would be for our cards that we showed earlier, what we would do is the controller would then database access, grab every building it needs, and then filter that out depending upon whatever the user selected, throw it into a view model, throw it back to the view, and say, I'm done with this, we're continuing on.
So now for our current progress. At the moment, we have all of the entity framework models ready for use, or at least all the ones that we think we need. That's subject to change possibly. This semester we focused mainly on the administrative work. So we have add floor plan done and manage floor plan done. And then in addition to that, they can like partially draw on the floor plans, but that's still in progress. We're hoping to have that done hopefully within the first 2 weeks of next semester. And then lastly, we got the corner detection draft, which you'll see on this next slide. So MDOCV is an image processing library that we used. Originally, we were going to have administrative users click on each individual corner of a floor plan in order to label the coordinates and give like the room's boundaries. But then we decided that would be very obnoxious, and McCower suggested that we look into image processing libraries, so we did. It turns out that we can do corner detection with them. Let me try to get this video here. So we start with a basic floor plan like this. As the video goes on, you'll see that it finds all the corners of it and it puts these blue dots on it. So now we have all the coordinates of the corners in that image. We can use that, we can send that to our canvas that we're going to be using in the draw floor plan view. And then we can pre-populate all the corners for the user instead of them populating it for us.
So originally we had a, we just used the native HTML5 canvas, but it's not very intelligent. It doesn't store, like it's very difficult to actually select any other points after you've drawn on it, because there's no way of remembering it. You have to do it all yourself. We did not want to do that, so we decided to use Fabric.js. The library, so we can not have to reinvent the wheel. Because Fabric is more lightweight than the other Canvas libraries that we found, because we don't need to do a lot of the animation or sound manipulation or the other stuff that also came packaged with it as well. While Fabric just supports resizing and moving, as well as click and drag of multiple points, which is one of the reasons why we actually looked into it in the first place. Unfortunately, we lost quite a bit of time because we spent a couple weeks on getting it to work without using any sort of library. This obviously would be used with an admin when showing which kind of what floors are actually, not what floors, what rooms are actually in the floor plan.
So as we're all aware, there's a semester ahead of us, and we will have more time to focus on burning through the features, since we already jumped through the hurdles of familiarizing ourselves with both the product and the process. So what we're going to do in the future is finalizing the features that populate the boxes for the student to actually select. Those features are, in the end, the most difficult features, and they are the foundation of our proof of concept. So we will have to make that proof of concept with high usability. And the student side of the app will reuse a lot of the code from the admin side, so it won't take nearly as much time. We will need to do some data manipulation to actually save the data of those students in the database.
And going through our process this last semester, we have learned a few things. And some of the key points are what our clients need is the proof of concept. So we should implement the functionality before making it look pretty instead of doing the same thing, doing both things at the same time. And the second thing we learned is that JavaScript has a ton of open source libraries. And each library has thousands of commits over the years and even until now. So rather than reinventing the wheel, we should implement those frameworks like the Fabric.js to allow selecting multiple points and the corner detection for high usability. And lastly, our team members vary in strengths and weaknesses, so we really value each other's help, and especially when the end of the sprint or the end of the week is approaching, because at those times, when we meet our sponsors, we really want concrete proof of progress to show them.
Do you guys have any questions for us? Thank you for listening.
Can you talk a little bit about your risks, the estimation mitigation method?
Yeah, so a lot of the risks were just, were a lot of mitigated because we're emulating the system, so a lot of risks were just getting used to making use of ASP.NET MVC, and the mitigation was just spending like, I think we spent like about 2 weeks in like our beginning sprints just to going through the tutorials and just going through and making like a sample project for ourselves and just trying to get used to that and get our feet wet.
So I don't know if you guys covered this, but one thing that I can see through the system is not only with like how SAS works, but when trying to pick a room, how are you guys handling the full load on your system? Because that can be a big issue.
That to us is not a huge concern because again, this is just proving that the experience is good and that the technology exists. When we handle load, that's probably more on their end, I think, when they break it down and integrate it into their own system. So a lot of the risks were mitigated by the fact that they're breaking it down and integrating it themselves.
Given that the focus of this project is more on the experience, the user experience, and anything else, what was your UI design process like, and how did you make, what were the most important decisions you made and how did you make?
All right, UI design process. We locked ourselves into a room for 4 hours and did an ideation session, just kind of going, okay, what is something that the user needs to do? And we just went on the board and just started drawing things and being like, okay, this is what I think would be great, this is what I think wouldn't be good, and just a lot of tempers and arguing until eventually we were like, okay, no, like, this makes sense, and just, it was just a lot of brainstorming and just forcing ourselves to do it, and then going back to the sponsor saying, hey, this is what we think it would look like, this is what we think would look good, what do you think? And they gave us some feedback and we went back to it.
Follow-up, do you plan to do, or what sort of testing do you plan to do if your UI to validate the decisions you made?
Testing for UI development, mostly going to be ad hoc us playing through it, but we're probably going to be looking into some of the more other web stuff that they have, such as I believe someone made Selenium maybe for web things, since we make
But more subjectively in terms of experience, not just
subjectively in terms of experience.
Or do you plan to reach out to other users beyond the development team?
Yeah, definitely. We'll probably be throwing it to some people that we know to look over it, especially since we have a plethora of people in our user group, right? And we're going to be doing this. Probably mostly worried about making sure they're able to quickly find what room they're looking for, but not so much as how long it takes to load, since that's probably mostly a loading concern for how fast the servers are, more for us, but like worried about how quickly does it take for them to find and filter out what they need.
So you're mostly focused on UI, but you mentioned that there's going to be overlap in the things that admins can do and students can do. Have you thought of like how you're going to reuse that code?
Yeah, ASP.NET and MVC has this really cool thing called partial views, where you can just throw it a certain kind of model that you want it, and then it renders it the same way regardless. So that card selection with the different buildings and floors is something we're going to be reusing for admins and users, so they'll be able to select what I want to edit and what I want to live in. This we're going to be reused for that. Also probably very similarly, the information we need to render a drawing of a floor plan is probably going to be similar to rendering what actual floors are there. Just slight different JavaScript implementations. All right. Thank you.
All right, so we are the financial literacy. We are working with Intuit on this. I'm Matthew.
I'm Peter. I'm Brandon Cornell.
Dan?
So we're first going to run over the agenda. We're going to look at the team intro, our goals for the senior project, our current status and how we got there, what we're learning, and our next steps going forward. And then we're going to have a quick time for questions. So our coach is Eric. We are working with him on this. We have a lot of sponsors. Two of the main ones are Rocio and Eliza. Everybody else kind of pops in when they can and tries to help out where they can. So the goal for this is to deliver a solution to help high school and early college students develop better practices with money, learning their habits, and being able to use it more efficiently. Two of the focuses that we focused on a lot were saving for a reward and avoiding money mistakes such as debt and accidental purchases.
So our current status, everything that we've been working on so far has been mainly creating prototypes that could either be writing pictures up on a board and taking pictures and showing people, or creating somewhat detailed mock-ups on different services that Intuit has provided us. Another thing is we've been doing a lot of contextual inquiry with a lot of students on campus, not only in GSIS, but all other colleges on this university. And then we've also been meeting with our sponsors a lot this semester, twice a week. It started off once a week, but we started to move more towards twice a week just so we can get more feedback from them and try to get a direction. How we got here. We utilized Intuit's method of starting really broad and moving narrow into something. So with that, we decided to try and hit as many people as we could by creating a survey. We sent it out to as many people as we knew and tried to get as many people to take the survey. From that survey, we ended up getting a lot of feedback based on some of the questions that we got. And from what we found out, we tried to make a wad chart to try and figure out the best way to categorize everything and see what the biggest problem was. And for us, we found out that not a lot of people knew how student loans work. So from there, we brainstormed heavily, and we ended up coming up with this design. So in the beginning, it's the basic login if you want to log in. But we also wanted to try and make an application that was easy to use that you didn't have to log into. So we had a basic starting point where you can enter the amount of debt that you're in, the interest rate that you're paying, and your planned monthly payments, and it would quickly show you how long it would estimate how long it would take you to pay off your loans. As simple as that. If you wanted to log in, this is the main page that you would see, clearly showing how much debt you're in, and we try to recommend if there's any refinancing options for you. At the bottom, we have a next payment slider, so you can see all of your payments, when you're supposed to pay them, how much you're paying, who is it going to, etc. And then a easy to move around calendar, so you can see see when your next payments are months ahead. And then all the way on the right is a projection of how long it's going to take you at your current rate. And you can always change it by going to your loans and updating your loans, adding new loans, deleting loans once you're done paying those loans.
Okay, so ultimately, after creating the idea that Dan just presented, we kind of had to shift customer focus, and this is due to two reasons. The first reason is that we discovered that there were similar products doing the exact same thing that we were thinking of. Some of the notable competitors were
Student Loan Hero, which is a product that did exactly what we were saying. It tracked your student loans, it did projections and everything else. And also due to another reason, which was we had a project sponsor who wrote the project proposal, and she was out in hospital for about the first half of the semester, and without her guidance, we kind of shifted away from the original intent of the project statement. And so that's kind of the reason why we have to shift customer focus back to a different arena.
With that in mind, we asked our sponsor, who came back from her absence, and asked her to explain and reiterate exactly what the original project statement was. And that was to shift towards high school students mostly, shift away from student loans, and develop good spending habits in these high school students. So later on, they'll be able to know their money and kind of be prepared for when they have a real paying job and won't acquire debt. So after we asked our project sponsor to reiterate on the original project statement, we did some more contextual inquiry using the same design methodology that Dan was just talking about, where we started narrow, or we started broad and went narrow. And that's currently where we are in process. We're doing some brainstorming ideas and doing a ton of customer interviews right now. So after we did some customer interviews, we came up with 2 ideas, and this is one of the ideas. So basically what we designed was a prototype called a savings tracker. Basically, it does what it says the name is. It's a savings tracker that lets users track savings goals. So this can be goals for either planning a trip to a different country, concert tickets, an Xbox 360, or some other product that you want to save for. And all these savings are manually inputted by the user itself. And the application doesn't actually contain the money at all. All that money is consolidated by the user. All the physical money is consolidated by the user. So let's say I want to save $20 towards an Xbox. I would actually put $20, the physical money, under my bed somewhere, and then I'll actually log it into the application. So although this might seem rather prehistoric, it's actually helpful and habit formed because it teaches the person to store the money and develop those savings habits of putting the money away physically somewhere else instead of just letting an application do it for you. So with that as well, we're also displaying savings graphically, and we discovered that we all know that people learn better through physical projections, or through visual projections, and that's what we want our application to be heavily based on, is projections. So we have that motivation alongside to help them save more and go for those savings goals, basically. Along with those graphics that we're showing for the savings, we also want to show some price history for the product that they want to save for. So for example, if I'm trying to save for an Xbox, what it'll show is the price history for the Xbox, so I can better predict when the best time is to buy that Xbox or whatever product I'm saving for. Another thing that we want to include last is a tip section to kind of teach users how to save money if they don't have a part-time job. So for long-term savings goals, some things I could do is basically save for retirement, or put money in my retirement fund, or do some trading, or kind of different ways to acquire money without a job, basically. So these are these are some screenshots I want to show of the application. So as you can see, the first screen all the way on the left, or your left, is a dashboard. Basically what it has is all the savings goals that you're saving for. And at the top, there's a little blurb that says, congratulations, you've saved a total of $521 so far. That's around $200 slices of pizza. So what we want to do in that little blurb is kind of say exactly how much money you spent, as also a little motivation factor. And then also have a little tidbit, a little fact, equating that monetary value to a fact. So in this case, it's around 200 slices worth of pizza. For me as a user, so for this instance, it's basically you're logged into the application, and for my preference, I like pizza. So the little fact equates it to something that I'm into that'll motivate me. So as I talked about, there's 2 savings goals there, the Xbox and a car. So as you can see, I'm 20% left for that savings goal. So I've saved a total of 80% so far, and there's a little motivating label that says almost there to kind of keep that motivation going as well. So under each savings goal, there is a little picture to show what you're saving for as well. On the right side, there is a screenshot of the tip section I was talking about, where it'll tell you some ways you can save money for long-term goals or short-term goals, basically. So these are all screenshots of what it looks like when you go deeper into each savings goal, so look at the details of it. So at the top, it says the basic amount, or all the amount that you saved for that goal. In this case, it's $299 so far, 30% left to hit your goal. Also, the little image below it, so it's kind of has the same image, or the same details as it does on the dashboard, basically. Below that, there's a collection of graphs to show you more information about your savings goal. So the first graph you can see all the way on the left is the progress bar, so the same progress bar that was shown on the dashboard. The second graph is the middle screenshot. Basically, is a projection of how much you've been saving, and kind of simulating or projecting and telling you how much time you have left until you hit that goal. Lastly, the last screenshot is the price history graph for the actual product you're saving for. So it tells you the price of your Xbox or whatever product you're saving for, and then a little graph. So you can either, in this case, it doesn't show it, but you can change the date and time you want to show. So if you want to show the monthly prices or the daily prices, you can do so. Below each screenshot, you can see that there is a way to add and remove money from that savings. So that's the part I was talking about, where you're actually just adding money into the application itself, and you can remove money when you want to. So if you happen to go into that stash for your Xbox, you can always remove money from the application side.
And the second idea we came up with during the cycle of contextual inquiries was an app we called Potluck. This was more focused on the social aspect of saving, more specifically saving as a group, or a parent and a student, or a parent and a kid saving together. Our sponsor wanted us to focus on the social aspect of saving as well. So this is an app where you can create a group, and there's aspects where you can throw money into kind of like a pool, and you save as a goal. So you save as a group toward a common goal. So for instance, if we were one group, we would be saving to go to an escape room, and we'd all input what we have for saving toward the escape room into a common collection, and we can see our group progress. We can encourage each other on through chat options, and we could. There's also other fun stuff we would incorporate into the app, like rewards and trophies, and we would incorporate rewards and trophies. It's not monetary rewards, it's more like kind of like achievements, just to get users more involved in the app and to get them to come back. So it would be like daily rewards, and such rewards would be like emojis that we would use to display progress or to display completion of a goal or item. A couple of screenshots of the mock-ups we came up with this app was, this would be a home screen for a user where they have all their groups listed, all the current items they're saving for that respective group, along with the cash they have saved for that group. By swiping left, you can have the option to leave the group at any time. You can also edit your personal info if you want to give yourself a fun nickname for a specific group, or if you changed addresses, phone numbers, that would be the place you can go and change that information. You can add groups and create groups through this home portal. You can also check your history, and by checking this history, it'll give you a bunch of statistics on how much, like what percentage of the groups you're in actually save for that reward. How much are you averaging saving for toward the goal? Are you leaving groups often? Are you actually staying toward the end? So it gives you kind of feedbacks about how you are saving money and how you are progressing toward goals throughout time. And there's also an option to add payment if we so choose to incorporate real-life payment through this system rather than just the trust system of I have $20 saved. And this screenshot would be what a group home would look like. You have all the people in your group listed along with where they currently are in terms of the savings. And once they hit that goal, as I said earlier, there's like a fun emoji that would pop up that would just say, oh, Matt and Dan have reached the goal while me and Brandon are still getting there. And the progress of the group would be displayed along with the group goal and the person goal, so you know overall like where the group is and how far you have to go. You can also change the goal item you're saving for at any time by clicking a button right under the progress bar. And you can also enter the chat feature through this home portal. You can also input your payment or how much you have saved and put away for this particular item through this home screen as well. And to reiterate our current status, we're currently doing more customer inquiries, and we're still coming up with original content, and we're still trying to find that one niche to solve the problem out there that our sponsor wants us to solve for. As we'll discuss shortly, we are having a little problem finding people to interview in the specific demographic, as we are supposed to be focusing on high schoolers, and a lot of us being seniors in college, we don't have that many branches down in the high school level right now, but we do think we found a way we can reach a broad subject pool to take surveys, and we can really find the actual problem out there that we can solve in this particular domain.
So what we're learning a lot about Intuit's design and thinking processes, how they get to their ideas, the type of tools they use. One tool that we are using, that they are using, is mockups, which is a prototyping tool that allows you to draw your screens and then link them so it flows somewhat like an app. So when you're doing a survey with a person, a customer right there, you can actually flow through it and get their total experience. We are also using a lot of different survey techniques to gather data. So we're learning a lot about the questions and how to phrase them so that we get relevant information for what we're looking for. We've mainly been using Google surveys for right now. We're soon to be reaching out to SurveyMonkey because they're going to be able to reach that lower demographic for us. It's actually more relevant for us. We're using this data to look at customer trends to figure out where we need to target. So our next steps, we are still working through the customer surveys, looking for more customer trends. We're going to be using this data to come up with more ideas and hopefully have a good idea by mid-January and start giving Intuit some more prototypes and a finalized idea. Any questions?
Can you talk a little bit about metrics?
So for this instance, since we're still doing the contextual inquiry part and brainstorming sessions, we don't have really metrics to decide, I guess, whether we're on the right track or not. It's mostly, I mean, some metrics I guess we can use are, after we do customer interviews, we synthesize work notes from that, and then we see if they match up to our brainstorm, to the ideas that we're coming up with. And then afterwards, we're presenting it to our project sponsors at our weekly meetings and seeing if they're agreeing with it or if it's the right direction for us. So I guess there aren't really any strict metrics currently, but yeah.
I guess I'm just curious as to why the requirements phase is taking so long, and like how you will know when you're ready to start building something. You guys, so what is the customer not happy with like the requirements that you've come up with so far, and they just don't want to proceed to the development stage yet?
Yeah, it's kind of half and half. We are presenting our ideas to our project sponsors, and there isn't some kind of connection between the two. Like, they're not feeling that physical or spiritual connection with the ideas that we're developing or presenting to them.
I guess I'm just confused because usually the client gives you the...
Yeah, in this instance for our project,
we had to come up with the idea on our own. We were presenting with kind of like an idea, like students that are in high school are having problems understanding financial literacy and having problems saving. How can you solve this problem? So they came to us with an idea, and within that idea, we needed to solve a problem that we discovered on our own. So it's kind of a different aspect of a senior project rather than having the project delivered to you from the start.
It's kind of the same thing that Dan was talking about too. With their methodology of going from broad to narrow, they gave us a broad project statement, and they're making us go narrow. So that's why we're still in that process of kind of narrowing down on idea currently.
Were there any specific requirements, techniques that you used from our prior classes that helped in the design together? And then maybe just read into it. I said that, and then
444 is or 440. 444. Yeah, 444 has definitely been a huge help. That we're primarily doing a lot of UI mockups, a lot of customer inquiry. We've made one WAD. We're probably going to make more, and all of those techniques are really helping us try and find what we're going to make.
what communication channels do you use to communicate with your sponsors? It seems with such a high number of sponsors, it would create unique challenges there.
So Intuit uses BlueJeans, and we originally met with them in person for our first meeting, and from then on out, we've always met on Thursdays. We talk on Slack the majority of the time, yeah, so we're always in communication with them. So All we know every week that we're talking to them Tuesday and Thursday, so we always log into the same Blue Jeans meeting number, and we meet with them.
Okay, thank you.